It's Mr. Van Long here with Distance Learning Week 5, Day 4, and we are in Chapter 12, Lesson 4. We're going to be looking at the sides and angles of quadrilaterals. We're on page 923. Now, kind of like the triangles being divided up into two lessons, the first time we were just kind of looking at them and observing them, and then we really went into classifying them. That's what we're doing here too. We're kind of just making some observations about quadrilaterals, four-sided polygons. And then we're going to really classify them tomorrow. Now, quadrilaterals, what you really want to pay attention to is the number of, okay, so tomorrow, the only thing that we really pay attention to is if they've got right angles and if the opposite sides are parallel. Today, we're going to be looking at if the opposite sides are congruent and parallel and counting how many as well as the angles themselves. So we're looking at the sides and the angles, the opposite angles and the opposite sides to see if they're congruent and parallel. But tomorrow, doesn't really matter if they're congruent. We're going to be looking at right angles. I might have whispered so much you couldn't hear me, but that's kind of fun because we have to wait till tomorrow to find out what I'm talking about. So before we get started, we got to talk about what parallel means. We know what congruent means. What's parallel mean? Parallel is when two lines will never touch. Two lines would never touch. Parallel means two, or it's not necessarily two. You get more than two lines that are parallel. Lines that will never touch. This is a great definition for elementary school. You're going to get into more specific definitions of what parallel means based on other criteria later on. But for our intents and purposes, we're going to think of parallel as meaning two lines that would never touch. So what we'll see in these shapes are line segments, right? So you're going to see line segments. Like my elbow to my fist is a line segment. My arm doesn't go forever in both directions, right? This is a line segment. But I could pretend that it extended out forever in each direction. So if I'm going to check with my arms to see if my arms are parallel or not. If my arms are parallel, then we could imagine that if they went forever, they would never touch. Okay, so this is parallel. If they're like this, if it went forever, see how they would cross? So this is not parallel because they're crossing. How do you remember what parallel means? Well, there's these two L's in parallel that are parallel to each other. There's like this example in the word. I don't think anybody did that on purpose, but man, it's great, isn't it? So there's an example of parallel lines in the word. And in fact, shorthand for parallel, when you're just quickly writing parallel, like in geometry class later on in middle school and high school, that's the symbol for parallel, two parallel line segments, which are literally in the word parallel. So that's kind of nice. So line segments, lines that would never, ever touch each other, ever, okay? If they went on forever, they would never touch. Okay, so, and then congruent is equal, and sides can be congruent. Angles can be congruent to each other, but angles aren't ever parallel. That's not the thing. So, at least I don't think it is. Maybe I lied. Hopefully I didn't. Who knows? So if we look here, we're looking at their four different figures, four different polygons. All of these polygons are quadrilaterals. And I want you to say on which of these the opposite sides congruent. When it says opposite sides, it means like pick a line and look at the line on the opposite side. Not every polygon could you say, look at the opposite side. Like in a triangle, you'd be like, well, there's sort of two, right? In quadrilaterals, we always think of a quadrilateral being formed by two pairs of opposite sides, okay? So in figure 1, there's the like more sideways lines. Those are opposite of each other, kind of up and down. And there's the sort of left and right-ish lines, and those are opposite of each other. Are any of those opposite pairs of sides congruent? Is this line the same length as that line? Nope. Is this one the same as this one? Nope. So figure 1 does not have any opposite sides that are congruent. What about figure 2? That does look like it's the same length as that one. And this looks like it's the same length as its opposite side as well. So we would write here that opposite sides congruent. Well, figure 2 meets that criteria. And so does figure 3. Those opposite sides are congruent. And so does figure 4. So 2, 3, and 4 all have opposite sides congruent. Cool. Now we're going to skip down and look at opposite angles congruent. So opposite angles. So here we've got this angle compared to the angle on the opposite edge over there. That's not the same. Those are not equal. And that's not equal to that, I can tell quickly. So it's not that. What about this? That looks like it's the same as that. And that looks like it's the same as, okay. 2 has opposite angles congruent. What about this one? These are all right angles. So those are total. I mean, that's congruent to that. That's congruent to that. Same with this one. These are all right angles. Those are all congruent to each other. So 3 and 4 are also congruent. What? Maybe it's a coincidence. Maybe it isn't. It's not. When the opposite sides were congruent, the opposite angles were congruent too. What about opposite sides parallel? Like if these lines went forever, would they ever touch? Nope. What about these lines? Would they ever touch? Nope. It's the same. We got 2, 3, and 4 are all in a situation where they never touch. But on this, like this right here, if this went forever, kapow, collision, right? So those are not parallel. And right here, these almost look like they're parallel, but if you kept going far enough, over here, kapow, it would collide as well. So figure 1, tomorrow there won't be any special words for it. It's just a quadrilateral, okay? But all of these other shapes, they have special classifications because they've got opposite sides parallel and because there are right angles and things like that. Okay. Turn the page. You can skip that talk about it section because I said so. Next, we've got some more figures. Try this one on your own and then pause. So you're going to pause the video, try to do the same thing for these ones, and then we'll compare work here in a second. Wow, thanks, Maya Math. They really mixed that one up. Look, it's the exact same answer. Figures 2, 3, and 4 all have opposite sides congruent, parallel and opposite angles congruent. I don't know why they made it like that. So it's not like every answer is figures 2, 3, and 4. That's just how they wrote it. I want to point out they didn't make a particular shape. And as I glance over here, they also don't make a special shape at all on this that we are going to be talking about tomorrow. So I want to draw it on the board for you. The special shape can look a lot of different ways. One way to draw it would be to draw it like this. I could also draw it like this. There's a lot of different ways to draw this shape. But what I'm trying to do right now is to draw shapes where there is one pair of parallel sides. The symbol for parallel is called a caret, and it's just a little sideways V. So just like we were showing whether things were congruent with a certain number of hash marks, we can show what things are parallel to each other in geometry with a note-taking method like this. This is parallel to that. So because I put one little caret mark in each of those, I'm saying those are parallel to each other. So there's one pair of parallel sides, but these would collide up here, right? Kapow, right? So over here, again, there's one pair of parallel sides, but these would collide together. So it is possible. The book, I think, makes it kind of look like maybe if there's one set of parallel sides that all the sides are going to be opposite sides are going to be parallel, and that's just not the case. So I want to make sure that you see it is possible to draw quadrilaterals with only one pair of parallel sides, or like a lot of these with 2 pairs of parallel sides, or with no pairs of parallel sides, like we've seen in figure 1 in both those examples. Okay, I want you to jump to practice it. Again, you can skip the talk about it. In the practice it section, notice that it wants you to focus on, instead of like in the examples, focus just on figure 1 and answer questions about it. Now you are allowed to write more than one word in here. So you are either the sides, we're classifying sides based on if they're parallel and if they're congruent. So you're going to say opposite sides are, you're either going to say parallel or not parallel, and either congruent or not congruent. Incongruent is a word, but you can write not congruent. It's fine. So yeah, you do fill in every little blank there and do your best to answer these questions. We're going to get into the nitty gritty of classifying these tomorrow. We're just sort of, again, today, observe quadrilaterals and notice things about their sides and angles. And tomorrow, we'll classify them. See you tomorrow.